So today we're going to be multiplying a monomial by a monomial. And before we get started, there's a couple of things that I wanted to mention that's going to be important for us to remember. So the first thing was that when we're using algebra tiles to find the product of our two monomials, we're going to be using something called the area model. When we're using the area model to find the product of our monomials, we're going to be filling in an area that's outlined by the two tiles or the two factors. The second thing that's going to be important for us to remember, and it'll make more sense once we do a couple of examples, is that when we're multiplying without using algebra tiles and we're multiplying monomials, we're going to have to consider the numerical coefficient and the literal coefficient in the terms. So let's go ahead and take a look at an example with some algae tiles. We're going to use the area model to find the product of two monomials here, and I've got it set up in this cool little T shape. And the two monomials that we're going to be multiplying are 2x and 1. So when we're multiplying two monomials using the area model, the first thing we need to consider is the vertical length of our first monomial. And the second thing we're going to consider is the horizontal width of our second monomial. Now, based on these dimensions, we need to determine which tiles would fill in the area that we have inside. Well, it would be an X tile that would fill this length and this width, and again, it would be another X tile that would fill in this length and this width. So based on the area model, we've determined that the product of 2x and 1 is 2x. And that makes sense because any term multiplied by 1 or any number times 1 is simply that term or that number. So just to take a look at a little snazzier representation of the area model, when we multiply 2x by 1, we know that we got 2x. Looks a little neater with the green X tiles than it did with my last drawing. I want to mention that when you're using the area model to multiply monomials, if you don't get a rectangular or square area inside, then something's gone wrong for you. If you're getting some funky shape other than the rectangle or the square, ask for some help because you've gone wrong somewhere and we want to help correct you with that. So let's take a look at another example. We're going to multiply 2x by x here. And again, we need to consider the vertical length and the horizontal width of these tiles in order to determine the product of these monomials. For the area here, based on the length and the width, it would be an x squared tile that would fill this area. And again, it would be based on the length and the width of these tiles, another x squared tile that would fill this space. Based on the area model, 2x multiplied by x is equal to 2x squared. And again, we can see it here. 2x times x gave us 2x squared tiles, so 2x times x was equal to 2x squared. So grab a piece of paper. Now it's time to try an example on your own. I've set you up with a question. You're going to use the area model to determine the product of two monomials. So what are your factors? What are the monomials that you're multiplying? And what is the product? What tiles are going to fill this area? Pause your video because it's going to take you a little bit of time to do this, and in a moment we'll take a look at what you've come up with. So did you determine your factors to be negative 2x? Because remember, the white side of tiles are the negative, and your second monomial would have been 3y. Now the area that you would have filled, so the product, would have been based on the vertical length of the first monomial and the horizontal width of the second. The tile that would fill this length and this width would have been a negative xy tile because remember, a positive and a negative multiplied make a negative. And underneath, the same thing, a negative xy tile would fill this space. And again, based on the length and the width, a negative xy tile. And all together, to fill this area, it would have taken 6 negative xy tiles. So based on what we've come up with using the area model, the product of negative 2x and 3y is negative 6xy. And if it helps you at all to look at a little neater diagram of this area model for this example, negative 2x was multiplied by 3y, and the product, which was the area filled inside, resulted in negative 6xy tiles. So I'm sure the question on everyone's brain is, what about if we're going to multiply and we don't want to use the area model and we don't want to use algebra tiles? This can be done. We need to multiply monomials and consider the numerical coefficients and the literal coefficients of both. So here's an example. We have negative 4x multiplied by negative 7x. What we need to do is we need to multiply the negative 4 by the negative 7, and we also need to multiply the x by the x. So we need to multiply negative 4 by negative 7, which results in 28, and we multiply the x by the x, which results in x squared. Negative 4x multiplied by negative 7x is equal to 28x squared. Let's take a look at one more example, and this one's going to be a little trickier. Remember, when we're multiplying monomials, we need to multiply the numerical coefficients and we need to multiply the literal coefficients. Negative 2x times 5xy. Well, negative 2 times 5 is equal to negative 10. We need to multiply x by xy. This is going to result in x squared y. If that doesn't make sense, let's think back to our chapter 1 when we did laws of exponents. X times xy. What are the exponents on the variables in these terms? Well, x is the same as x to the 1. We just don't write that 1. And xy, the exponents on each of the variables in these terms, again, are 1s. So using our laws of exponents, when we multiply powers, we keep the base the same and add the exponents. x1 times x1 resulted in x squared, and y to the power of 1 remains y to the power of 1. We just don't typically write y to the 1 or any power with the exponent of 1. So there we have it. When we multiplied negative 2x and 5xy, negative 2 times 5 gave us negative 10, and x times xy gave us x squared y. Altogether, the result of our answer, the product, negative 10x squared y. So here's your to-do for tomorrow. I want you to have an entrance slip ready. I want you to create an equation to find the product of two monomials. So create this question and have it ready to share for your classmates tomorrow.